Okay, in this video, we're going to be talking about something called a Taylor series. And in the very next video, we're going to be talking about something called a Maclaurin series, and that's just a special case of the Taylor series. But let's talk about Taylor. It says, let f be a function with derivatives of all orders throughout some interval containing a as an interior point. Then the Taylor series generated by f at x equals a is equivalent to the sum from k equals 0 to infinity, and it says f to some power k, and it's really not the power so much as it means the order of the derivative, okay, of a over k factorial times x minus a to the power k. Now, that may look very fancy, but it's actually really, really simple. All right, it is equal to f of a plus f prime of a times x minus a plus f double prime of a over 2 factorial times x minus a squared plus so forth and so on. The nth order derivative over n factorial times x minus a to the nth, and so forth and so on. So up to this point, you've probably been talking about sequences and series for quite a bit now, and I really hope you didn't forget your derivative rules, because you're going to need to know them right now. Okay, so what we're going to do is we're going to take a look at this function, and we're going to take the derivative because there's a few things that we need to do, and really it's all a matter of plugging in into a formula. And so the first question that we're going to look at says, find the Taylor polynomial of order 3 generated by f at some point x equals a. All right, so we have f of x equal to, now I'm going to rewrite 1 over x plus 10 so that I can easily take its derivative. So I'm going to write it as x plus 10 to the minus 1. All right, but just remember that it is equivalent to 1 over x plus 10. All right, now we take the derivative. Now this one right here is a chain rule problem. So what does that look like? Okay, well, that is going to be a negative 1, bringing that down, times x plus 10. All right, we subtract 1 from the exponent, so this becomes a negative 2. And again, you multiply by the derivative of the inside, but that's just 1. Okay, if you wanted to clean it up just a bit, you could say that it's just negative 1 over the quantity of x plus 10 squared. Okay, nothing to it. Now we find the second order derivative, f double prime. All right, and we're going to say, okay, this is a no-brainer. This is going to be a negative 2 times a negative 1, so a positive 2. And again, it was multiplied by 1, so we don't really need to worry about that 1 there. But a positive 2 times x plus 10, and negative 2 minus 1 is a negative 3 multiplied by 1. And so what we get here is a 2 over x plus 10 to the third power. All right. And now we take the third order derivative because it says order 3. So we have to take the derivative one more time. Now, normally you might say f triple prime, but let's go ahead and get into this notation that they've devised for us here. And that is that we're going to take the third order derivative just like that. Okay. So we have a negative 3 times 2, all right? So we can write the 2, multiply it by a negative 3. We have then x plus 10 to the negative 4 multiplied by the derivative of the inside, which is 1. And when we clean this up a little bit, we get negative 6 over x plus 10 to the fourth power. Okay, so we've figured this out. Now our job is going to be to evaluate this at x equal 1. So when I say x equal 1, I'm going to plug in 1 into f of 1, f prime of 1, f double prime of 1, and f triple prime of 1. And then I'm going to get the coefficients that I need for my formula. All right, so once I've done that, I'm good to go. So f of 1, this is 1 over 1 plus 10. This is 1 over 11, in other words. Now I check f prime of 1, f prime of 1, and this one right here is a negative 1 over, and I have 1 plus 10 quantity squared. This is a negative 1 over 11 squared, so negative 1 over 121. Okay, now look at the formula when you get to the second derivative. This is where it changes just a little bit. You have to divide by the factorial. So this one right here, we're going to say is going to be a 2 over 1 plus 10 to the third power, okay? And then we're going to multiply it by 1 over 2 factorial, which is just 2 times 1. So in essence, what ends up happening, the 2 crosses out the 2 factorial there, and you are left with 1 over 11 cubed, which works out to be, I'm sorry, not, let's see, what is it? Yes, 1 over 11 cubed, which is 1 out of 1331. Okay, so just like that. All right, now we find the third order. All right, so let's see what the third order derivative evaluates to, f triple prime. And I need to follow my own advice here, and I need to say f triple prime like this. All right, so what does this one look like? This is a negative 6 over 1 plus 10, and in this case to the fourth power, multiplied by 1 over, and in this case it's going to be 3 factorial. But the 3 factorial is 3 times 2, which is 6. So that's going to cross that out right there. And what does that leave us with? This is a negative 1 over 11 to the fourth power, which 11 to the fourth power works out to be, I believe, 14,641. Okay. Now what we do is we're going to take a look at our formula. All right, so to generate the Taylor polynomial, all right, the Taylor polynomial here, we're going to call it P3 of x. All right, it is a polynomial function. The first thing we write is f of a. Well, we know f of 1 is 1 out of 11. We've got that down. Plus, now the coefficient f prime of a is a negative 1 out of 121. And then it says multiplied by x minus a. So in this case, it's going to be x minus 1 that we multiplied by. All right. And then we're going to add, and it says f double prime of a over 2 factorial, which we've already figured that out to be 1 out of 1331. Just like that. And that's going to get multiplied by x minus a to the second. So x minus 1 to the second power, plus, and then we have a f triple prime divided by 3 factorial times x minus a cubed. So that we figured out was going to be a negative 1 over 14,641 multiplied by x minus 1 to the third power. Okay, so I can clean it up just a little bit more. All right, and it's going to look something like this. It's going to be 1 out of 11, and then I'm going to say minus x minus 1 over 121 plus x minus 1 squared out of 1331, right? Plus, or in this case, minus, all right, x minus 1 cubed over 14,641, okay? So understand that this Taylor polynomial is the one of order 3, but you could have gone beyond this order because you just have to keep taking the derivative, and you can take the derivative as many times really as you need to for these. So just watch out for the order that they're asking for in the problem. Okay, so let's go ahead and take a look at another and one more example here, the last example. All right, we're going to generate a Taylor polynomial from f of x equal x squared plus x plus 1 about a equal 9. Now this one right here, all right, this one right here is rather interesting because you're going to run out of derivatives. All right, so let's see what we've got. Let me see. Let me follow my convention here with blue. I'm going to first take the first derivative, f prime of x, and that's just going to be 2x plus 1. And now I take my second derivative, f double prime of x, and that's just 2. Now I take my third order derivative, f triple prime of x, and I just have 0. All right, so now what I do is I evaluate f of 9 into my polynomial. So you plug in 9 there, 9 squared it's 81 plus 9 plus 1. So 81 plus 9 is 90 plus 1, that's 91. All right, now I'm going to evaluate f prime of 9. And what is that? That's just going to be 2 because it's a constant function. And then I'm going to have f double prime of 9. I'm sorry, this is not 2. My mistake. 2 times 9 is 18 plus 1. That's 19. Now I'm going to try f double prime of 9. And that is just 2 itself. Okay, but then you have to multiply by 1 over 2 factorial, which ends up making this simply 1. All right, and then f triple prime, and I'll write it with the order 3 there, of 9 is simply 0 times 1 over 3 factorial, but that's just 0 right there itself. Okay, so let's take a look at what the Taylor polynomial order 3 would look like for this. All right, so we're going to start off with 91, which is our f of 9, plus f prime of 9 times x minus 9. So we're going to say f prime of 9 was just 19 times x minus 9. All right, plus, and then we have 1, so we don't need to really write 1. So we're just going to multiply then by x minus 9 quantity squared. Okay, and we've generated our Taylor polynomial right here. Okay, and I think I forgot to box the Taylor polynomial over here. Let me go back and do that. But my challenge to you, here's my challenge. All right, I'm not going to do this, but I'm going to ask you to expand this. Okay, expand this and see what you get, and see what the connection might be to that right there. Just a challenge for you, something to think about. But as always, I hope this video was helpful, and remember, like and subscribe.